We'll start. Hi, hi everyone. Welcome back to Deep Tech Forum. And next we have Catalyst Aerospace Technologies with the CEO Ivan Makarov. Ivan, welcome to Deep Tech Forum.
Thank you, Rico, for an invitation and for chance to talk here. So my topic is about how we will able to handle the complexity of the aerospace autonomy. And the reason I'm working on that I believe that we are living in the golden age of aviation and in the golden age of space. Because I believe in the 15 years, the flying area will change dramatically. So what we're working on today is more about terrestrial applications. We have in a product stack hardware, embedded safety critical software, which working on our hardware, and then it's supplied to the customer vehicle. And we have a technology to very efficiently adapt all this stack to the specific vehicle. And it's adapted by the online web-based application, collaborative web-based application, and it leverages the power of the market, of the vendors, of the functions they already implemented in the hardware. We have a very efficient way to integrate this hardware and to put it on the our hardware and install it on the customer vehicle and do it in cycle simultaneously and scalably. So I want to start with the vision I have for the future of this technology. And we see the global space of flying. So it's literally space. On the surface level, we got emerging technology of cargo drones, urban air mobility, when we're able to connect communities, cities, and just to live in more harmonized way. Of course, we will evolve technologies of troposphere flying, like conventional airplanes, electrically powered airplanes will evolve also. And also we go higher and faster. Definitely in this century, some of us will have a chance to fly on hypersonic vehicles, to have just to fly over the ocean within 2 hours. And also there is opportunity for rockets for transportation, even to ground. I think that's today it's mostly military, but who knows? And this is a typical mission we already have today. But I believe that as soon as cost will go low, we will see this market exploded. Satellites, more satellites on board, cheaper launching, a lot of platforms. And then we go to upper stage to have habitat facilities on the Earth orbit, factories, and also factories on the moon as the ramp to the interplanetary and the whole solar system, and to mine resources and explore and populate the rest of the solar system. And this is like typical descent mission that says that it's space connected bidirectionally. So we're able to fly there and come from there back to Earth. But still, we are in the 2021, and we have working on mostly terrestrial flying application within the urban air mobility trend and middle mile delivery, because this market is already emerging. And it faces problem of the jam traffic and poor road network, and still lack of infrastructure in some places. And the urban mobility technology addresses these challenges and problems. If we see that on the kind of helicopter view, this is the way of how this technology may change our lifestyle. So this is 30-minute commute time in the radius of that distance, we may see that using flying vehicles for everyday commute may increase our distance, and where we be able to choose where to live, closer to the nature, to the ocean, to the place we actually like, but not struggling in the city's jungle or something like that. So this is about the Los Angeles area. This is Singapore area. And also there is some cinematic vision, fifth element, how it may look like. I think this may look like when we will reinvent the source of flying, and it's not obvious how it may see in real life. And then I want to talk about the same day logistics. So the trend we are currently in is about same day delivery, when the consumer gets their goods from the internet store within the same day. And the next concept is that supply chain of the high-tech industry may be connected by the flying aircrafts on demand, connecting the whole supply chain in just-in-time paradigm for lower the cost, customize value, etc. And these robots, flying robots, may, as I see, it will take the place where actually industrial robotics is today. It's became industrial commodity, and I believe that in the 10 years, unmanned air vehicles for cargo, logistics, middle mile delivery, and last mile delivery will be the same commodity as the industrial robots are today. And but why we're actually not there yet? Because it's so much room for that technology. This is like a nice example of how usually dialogue is looking like. If you know this movie, you probably like it. So usually startups and the people expect that certification will take 1 or 2 years, and certification is crucial for scalable operation. And all the time I see hear from the startups that current bottleneck of technology is the regulation. And I disagree with that, because regulation is about to how make this technology reliable and scalable and safe for the public. And this is about technology and how this technology may prove that it's viable and scalable and able to provide same level of safety. And this is actually how it happens in real life. So usually the startups struggle within the certification and development because it's really hard. And in a comparison to the ground thing, I want to make some comparison. Flying cars versus cars. What differences? The first one is the complexity of the motion control. Aircraft has 6 degrees of freedom, and it is mainly unstable, in opposite to the car. And if something fails on board the aircraft, it has to adopt the redundancy or struggle for survival by any means it has. And car may mainly just stop. But in the environment stage where it's flying, it's actually for aircrafts, it's just less, nearly empty space, less dense, and same time for cars it's complex and uncertain environment where it's able to react in real time. And this is one of the concepts I want to put on table, that literally everything, almost aspect of the development of the hardware is the software. Because when we have some production plan or something, or technological process, is software which is to be executed by human or by any or by human system. And let's back to the flying vehicles. Major requirement here that we need to travel from point A to point B. Don't hit anyone and don't crash. And when it comes to real life, we need to apply RP 4754 framework, which is widely recognized in the aircraft authorities all over the world. And this is complex process which took hundreds of people to develop requirements, technical solutions, software and hardware, and then to certify it. Our technology is focusing to boosting up these levels. System level, item level, they are hardware and software safety assessment. What's the problem here? If you see from this V model, on every step, transition to every step, on every step takes conversion of the concept which actually team operates. From the business requirements, we need to understand how the aircraft will look like. For this transition, we need to aircraft people, airframe people. Then we need transition requirements from aircraft to the system level. We need system people. From the system level to hardware and software, we need hardware and software people. And then we need compilers to come from hardware, from the mathematical concept to from the software code to the machine code. And to go to the software code, we need to convert mathematical concept to the algorithm concept and to the source code concept. So a lot of transitions, which actually all these requirements, all this framework is about to make these transitions of the concept solid. And this is also popular meme how actually real life works. Different people have different assumptions, different understanding of the requirements, different understanding of how the things should look like. And this is the problem. This is the bottleneck. And then I want to put on table the following concept. What if instead of having processor when we have compiler to the machine code, assembly code, then machine code to the network on processor, what if we have processor that interprets and run on the high-level engineering domain concepts, high-level engineering configuration, high-level machine code. And then I want to present, and we're actually working on that. This is what actually we're working on. Here is the structure of how the software looks like. We divided it on the separate levels. Each level is separately and domainly orientedly configurable, like navigation, guidance, control, mission logic, health monitoring, redundancy, interfacing, sense and avoid. And here is the very simple example of how these languages look like. On the left side, I have an example of if I want to implement some rule, some requirement. If A more than B, then execute command 1. But actually, in real life, you want to filter some noises and glitches, and you want this expression to be true within some time. And here we have a different amount of code, which actually, when I wrote it, I made a mistake maybe 4 times. I believe that it's likely have a error, still has error here. But in the domain-specific language, we just have an temporal operator that wraps all this complexity in a very simple manner. This is just a single example. On a hardware level, we just built generic building blocks that configurable for each specific task very efficiently. So it's common base and with a different measurement or actuating functions. And then to configure that, to put all this technology, we built application on the web to be able to, from the upper level of the system understanding on the concept level, go down to the hardware understanding, logic understanding, algorithm understanding, and then transition to flight tests, and do this in a circle. And what about the certification? Working on the higher level of defining the system, we just still making transitions of some concepts on some algorithms, and we control that in this software application, in this web application. And then at the end, we able to generate reports, able to generate test procedures, the documents, human readable documents that will human execute on their position within their role, on tests, on manufacturing, on verification, on validation. So this system is around is built around the main dynamic domain model, which actually understands how this domain field is working, how one entity is related to another, because we configure our hardware by high-level concepts, and that's why we're not working with the lines of code. We're working with the high-level concept, what this line of code is doing. And that's why we're able to wrap a lot of degrees of freedom in terms of creating reliable, certifiable hardware and software. So, and on the certification perspective, it looks like that we have a pre-certified basis foundation, and on top of that we have domain-specific code generated from the application, which is actually 10-fold, 100-fold less in size than if it would be implemented conventionally. So here is the differentiation. There is some, of course, we're working in a field where there is model-based system engineering tools, but we're different. We do not generate code or execute for compile it for the, we generate configuration, which 100 times less in size. And here is the basics examples. These ones are not certifiable, but still I want to show you the difference. Usually for this kind of aircraft, you need at least 100,000 lines of code if you want this UAV reliable. And we need just 1,000 to configure the whole stack. 1,000 lines of code, of domain-specific code. And here is another example, a helicopter, which is much more complex. And here we have 7,000. And this helicopter able to fly autonomously from point A to point B, and even perform some safety functions. So I think that's it for my talk, and I'm ready for your questions.
Thank you, Ivan. I think some of our charts at the elevator pitch did ask some questions already. So just a quick one. When you're looking at the future of autonomous transportation, like when do you think this will become realistic in terms of the whole ecosystem we're creating?
I think in 10 years we will have this market will go from 0 to tens of billions USD. I think 10 years.
10 years.
It will rise urban air mobility and the drone logistics. This will be the first wave of the automated logistics, flying logistics.
So do you position yourself more of logistics and more of a supply chain in the aerospace technology?
we're focusing mostly on that that segment of the market because it's bigger. But actually, this technology is suitable for any kind of applications. For instance, agriculture. We have this kind of customers also. Um, any kind of task that actually flying, but we focus mostly on logistics because it's supposed to be much more bigger than the others.
Okay, I think that's all from my side. And thank you very much for joining us today, Ivan. We look
Thank you,
forward to
Rico,
more updates from
for the
you,
invitation.
and keep in touch. Talk to you soon.
See you soon, Rico.
See you soon. Bye.
Bye.
And thank you everyone for joining us at the platform. We will be back in a few minutes with another speaker. Thank you.